Let's explore Field Programmable Gate Arrays, or FPGAs. In this presentation, we will discuss the FPGA architecture and how they are configured. FPGAs are reconfigurable digital circuits that allow for custom hardware implementation, offering flexibility and adaptability in various applications. So, what exactly is an FPGA? An FPGA is an integrated circuit designed to be configured after manufacturing. The key feature of FPGAs is that they are reprogrammable hardware, which allows for custom digital logic implementation. This means you can change their function even after they've been made. Now let's take a look at the basic architecture of an FPGA. FPGAs consist of three main components: configurable logic blocks, or CLBs, routing or interconnect matrix, and input-output blocks. The CLBs are the basic building blocks that implement logic functions. The routing provides the connections between these blocks. And the input-output blocks allow the FPGA to communicate with the outside world. Let's dive deeper into the structure of a configurable logic block, or CLB. Key elements of a CLB are lookup tables, or LUTs, and flip-flops. LUTs implement the logic functions, while flip-flops store sequential data, allowing for more complex operations. Now let's discuss lookup tables, or LUTs, in more detail. A LUT is a memory-based implementation of combinational logic. A common size for a LUT is a 4-input LUT, which has 16 bits. Consider a 2-input AND gate as an example. The truth table shows the output for each combination of inputs, A and B. When both A and B are 1, the output is 1. Otherwise, the output is 0. Let's explore the routing architecture within FPGAs. The interconnect grid allows configurable logic blocks, or CLBs, to connect with each other. The key features are switchboxes, which route the signals, and the programmable nature, which means the paths can be configured as needed. Let's walk through the configuration process for FPGAs. The first step is VHDL design, where you write the hardware description in Verilog or VHDL. Next is synthesis, where the code is converted to logic gates and mapped to the FPGA architecture. Finally, the Bitstream is generated, which is the configuration file used to program the FPGA. Let's explore some applications of FPGAs. FPGAs are used in digital signal processing for image processing and real-time filtering. They are used in rapid prototyping for hardware validation and algorithm testing. They are used in telecommunications for network processing and protocol implementation. And they are used in embedded systems for custom controllers and hardware acceleration. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.